These are not your grandfather's tools.
Oh, okay. To be fair, this might actually be your grandfather's tool. On with the video.
Okay, welcome back. We have a lot of new followers here because I dared to say that there is no parts crisis in general aviation, or there should be no parts crisis in general aviation. To the new folks here, welcome to the Open Source GA channel. My name is Bonanza. I do airplane stuff. I try to inspire you to do airplane stuff. I try to offer up solutions for more airplane stuff. I'm not a person that just picks a topic and goes with issues. I like finding solutions. I'm an engineer. I'm a flight test engineer. I'm a pilot. I'm an owner. I'm a designer. I'm an entrepreneur of sorts. None of my businesses have ever been profitable, but that's besides the point. I am trying my very best to find solutions for some of the problems that we've been having in general aviation. Hangar availability, parts, safety, fuel availability, environmental impact. These are things we got to talk about. And just so happens that a lot of you found my channel because I talked about parts and making parts and bending parts and owner-produced parts. We're going to have to talk more about that, but with all the information attached as well. So here's what we're going to do today, or here's what we did today. This is some movie magic. It's coming at the beginning of the video, but it's really at the end of the day. I'm going to launch out of here, Savannah, Georgia, where I have a beautiful 1963 Beechcraft Bonanza model P35. I'm going to fly exactly an hour and a half to the north up to Greenville, South Carolina, where there is a manufacturing expo happening in this gigantic expo hall. Lots and lots of vendors, tons and tons of booths, and people showing off what's available in manufacturing technology. I'm not expecting that there's going to be a lot of aviation-based things or aviation-specific things, but all of the tools that are going to be at this place can, in some way, aid in the parts crisis and the development crisis that we're having for small general aviation airplanes. As a primer, what you're going to see is CNC machines, you're going to see lathes, you're going to see mills, you're going to see inspection arms, 3D scanning, 3D printing, you're going to see drill bits, you're going to see tool changers, you're going to see automation, robotic arms, all kinds of cool stuff. So stick around, let's hop in the airplane, head up to Greenville. In the past, you get what I'm saying. Let's go up to Greenville, do this expo right, look around, get some ideas, and then I'll report back to you on what's going on. Oh, by the way, I'm going to be flying with a really good friend, and I call him TI-85. Some say he is the cause of magnetic variation. Some say he doesn't need a ground power cart to start any of these airplanes. He simply does it with his sweat. TI-85. We're gonna also, because he's a CFII, do some instrument training on the way there and the way back. So this is gonna be a great video. Hope you stick around till the end. Like and subscribe. I hate asking for that, but that's the only way that the video ever gets shared and people realize that we can solve some of the problems. Instead of just complaining about it, I'd like to find some solutions for me and for you. I'm just hoping you decide to come along on the journey. So let's get into it. Welcome back. Thank you for being here.
November 36 Mike, wind at 310 at 4, turn left heading 350, runway 1, clear for takeoff.
Left 350, clear for takeoff, runway 1, 8636 Mike. Alright, your speed's alive. Making good RPM, engine feels good. Fuel flow's good, manifold pressure's good, there's flying speeds.
B1, rotate.
Rotate. Positive rate. Gear up.
Savannah Tower, November 7444 Tango, holding short runway 1 at Bravo, ready for departure.
Tower 44 Tango, Savannah Tower, roger.
Okay, hour and a half of flight time from Savannah up to Greenville, South Carolina. Not Greensville, Greenville. We parked the Bonanza, and it's within walking distance. We're over here at the exhibition hall. We're going to look at the future of manufacturing technology, or the present state of manufacturing technology, which for some of you folks might be the future. We're going to go prove that we can have solutions to our small general aviation problems. Let's go see what they've got in store. That's awesome. That is great. Oh yeah, I've had suspenders before. There we go. That feels nice. Right, kicking things off with a welding table setup. Who doesn't need a good welding table? If you're gonna be making jigs and things for building airplanes, there you go. Sigmund, very nice. They've got their whole lineup of stuff, from storage, the massive tables, 90-degree angle blocks, things that they've made. Yeah, you can start off easy. This is your grandfather's equipment. Welding. Let's go.
Some of these machines get really loud, so the best I can do is a voiceover. You're looking at a Waterjet from a company called Flex. It's really as simple as drawing out a part in SolidWorks or Fusion 360 or AutoCAD, getting what's called a DXF file or something similar. It's just a drawing from that software, and then sending it to this 4-foot by 4-foot table to be cut out in a Waterjet. On that particular machine, you could probably get that into your garage space. It's not cheap, but you'd want to commercialize it afterwards just to repay yourself the money that you spent for that unit. It's really great for cutting aluminum. It won't heat up the material. You won't have cracks around holes, but it's really nice stuff.
I'm Jawanza. Good to meet you.
How's it going?
Oh, I'm going well.
We're doing AI-based computer vision. So we're training deep learning models on images of parts, defects, surfaces, scratches, whatever you might have a guy looking at, trying to make an assessment on. Right. We want to train an AI model, integrate COTS hardware components with our software, and build something that'll make the operator a little more efficient, improve throughput, reliability, repeatability, all of that sort of stuff. That is great.
So the demo that you have running back here, it's identifying specific bits of hardware,
That's right? It's identifying and measuring. So next to each hardware, you see there's a letter which indicates the type of hardware, and then there's a measurement as well. That's the millimeter measurement. We can also track them, so we can put an ID next to it and then track it throughout the inspection. We can do both, although that's very hard to follow.
Yeah.
And then we have another demo that's doing defect detection on these cat food tubs. When the seals on these things are applied wrong, if the seal breaks, the food will spill out onto the edge.
Right.
And so we can recognize that as well.
So it's just picking, it's just saying, hey, there's a defect here. A human should come put eyes on this thing, right?
Yeah, exactly. It's saying I found a strip of food that's 23 by 7 millimeters.
Yeah.
And that's larger than the allowable tolerance for spilled product. So this has to be rejected. Obviously, if this were put in the box, it would spoil. It would ruin everybody else's cat food, all the other cans and all the other tubs. So you want to catch it early.
So how do you train that? Are you just saying, hey, here's 1,000 samples of bad cat food and
more like 150? But yeah, you take for this one, I took about 150 images. I annotated them, so I drew a box or a polygon around the areas where the product had spilled. So I indicated where that was to the system. Yeah. And then over time, through iterations of that, it's able to pick it up itself. Yeah.
So the problem, it's not really a problem for us, but it's an opportunity, right? So we work with a lot of hardware for airplanes, and there's only a small subsample of that hardware. It's AN insert thing here. It's an AN something washer, an AN something bolt. And after a long project, you're left with 1,000 extra washers and bolts, and you have to then sort all of those, figure out if the threads are marred,
If you could just use a camera pointed at it and it tells you what it is, that would be...
even this, just that first demo.
So, what sort of accuracy can you get with the hardware?
So, really, as much as you need, this is with a very basic Amazon $150 Amazon camera.
Yeah.
So obviously, with this setup, you're probably only going to get maybe a quarter of an inch, a tenth of an inch accuracy. Now, with something with a little bit better resolution and that's been tuned, better, we could go to probably to a 1000. We have one application that's at 50x magnification that we use to look at PCBs. So we can zoom in as much as necessary.
Okay, so let's talk a little bit about what we just saw. It's a camera system that looks at things that you train, and it knows whether a part is good or a part is bad. I'm pretty sure you can find applications for that in general aviation, putting down old bolts and screws, having it identify exactly what the bolt or the screw is, the length, the dimensions, the color, whatever it is, and sorting that, maybe with a robotic arm. But on top of that, looking at those parts that it's already trained on and knowing whether a part is good, it's deformed, it's marred, it's bent, it's scratched. See where this is going? All right, let's keep moving. Throughout the hall, there were displays like this, a CNC mill that was cutting a part in real time. I don't expect you to be able to afford one of these, but I just want to show you that some of the companies that we're using to make parts for general aviation have access to these types of machines. If we move down just a little bit further, we get to see a CNC-controlled bending machine. Here it is.
This would be cool to have. I mean,
you bring a credit card?
I don't think I have enough credit cards in my stack up to be able to afford one of these things, but that is too cool.
So think about your tubular steel type airplanes, like the Rans S10 that's sitting in my hangar. It's just made up of 4130 chromoly steel. And it's pretty blocky in design, but you could bend things now with these CNC machines and make it repeatable and just do cool designs that really bring back the ease of manufacturing something like a Rans S10 or steel tube airframe. I'm not expecting to be able to afford the unit, but I know that there are companies out there where I can send my designs and have them bend exactly that thing. Experimental aviation will really, really benefit from this kind of stuff.
Okay, so you know what I like? I like tube airplanes. I like fabric-covered tubular airplanes because they're easy, they're strong, they're easy to inspect, they're easy to repair. And if I had a machine that could put bends in tubes, or even, cope tubes automatically, we'd be changing the game. That right there is it, right? You throw down all your nuts and bolts, and it just kind of picks it up and sorts it.
So this is metal 3D printing, right? Like, just talked about this on the channel a few videos ago.
I'd be interested, I'm sure that would be interesting.
Yeah, you can't.
How's it going, yo?
Wow. Wow. So I'm super interested in your 3D printing metals. Is that right?
Yeah. So we're a machine manufacturer. We manufacture both metal and polymer systems. It's all powder bed based. So Our material all starts as powder. It pretty much starts from the beginning. When you're taking your file, it's kind of like with the desktop printer. You take your STL, you load it into your slicer software. With the polymers, we don't require any sort of supports, but with the metal, we do require supports. So the setup on the metals is somewhat traditional to your FDM. From there, once it's loaded in the machine, you press start on the machine. What will happen is the powder actually gets spread across the build platform in a very thin layer. For metal, it's anywhere from a 30 to 80 micron. Polymer can go up to 120 micron layers like this. What then happens is you'll actually have the laser come through, and that actually melts out the 2D shape. Then, of course, as 3D printing goes, it builds up over time, and then you just
stack.
Yeah. So with the polymer and the metal, what's nice about our process is you're getting a more solid part. So with the polymer, you're not having to worry about those layer lines. It's fully welded together, so you're getting kind of near injection molded, strength. It's not quite there, but we're really close to it. You know, with the metal, for example, we're getting a 99.99% solid part. So it's like near billet, you know.
Wow.
Our patented technology was DMLS, and we're actually like sintering on the build level. So there's no sort of real additives that you have to like melt away after. You know, other processes, you have to take that part, you know, clean the wax out and then fire it in a kiln and then worry about shrinkage. With that, you don't have to worry about
straight to finished part.
Cut it straight off the plate and the part is usable. It pairs really well with CNC technology also because there are some limitations like on tolerance and stuff that we can't necessarily do. But the CNC can come through, you know, clean up surfaces. If you need like a high precision tolerance, like on a hole for a shaft, it does perfect on that. Threads, you can put threads in. If you need sealing surfaces that seal well, you can mill those flat. So what it kind of does really well is you can get like that 90 to 95%, you know, near net blank.
And then just the finishing,
the CNC, finish those surfaces.
One pass operation pretty much.
There's a variety of materials as well.
Exactly, so we can do pretty much for like metals if that's what you're interested in, you know. It's all across the board. We can do aluminums, titaniums, copper, nickel alloys, cobalt chromes, tool steel, stainless steel. Copper nickel, you know, there's some blends in there too that are kind of interesting.
So, go ahead.
How does the stainless steel, for example, compare? I see it's 316.
That was exactly my question. In strength you know.
So this is pretty much straight 316. You know, we're not putting any sort of extra additives to make it more sintering. The difference of this though with additive is you are going to see a little bit less strength. You know, a few percentage less on like tensile and yield, elongation, but for the most part, it performs really freaking close. We see our parts actually, you know, we have manufacturers for aerospace that take the parts and they'll send them into space, you know. Ursa Major, for example, most of their rocket is additively manufactured.
I didn't know that.
So.
That makes sense because I saw someone online say, Ursa Major, they're 3D printing rockets, right? So I guess they really are.
3D printing rockets.
This is cool. This is it. So what kind of power, like what kind of facility do I need to run something like this? Or like who if I had the need to do this, who across the United States has the technology, the tools to be able to take my part and turn it into something?
So there are a few different manufacturers out there that we partner with. You know, they use our machines. You know, I want to say Centavia's one. We have a Pflugerville, Austin office, and right next door to us is another parts manufacturer that uses EOS machines called Cumberland Manufacturing. You know, there's Beehive. There's plenty of parts bureaus out there that just simply they'll take your part, and make it for you.
Make a part, Take a part, make a part.
There's a lot of, you know, the cost of entry on it is rather high. You know, one of our small frame machines runs for, you know, roughly about $800K. So just the machine in and of itself, it is a pretty high bar of entry, but you know, there are parts providers out there if you just need like one or two that, you know, will work with you on
that. That's exactly it. That's exactly what we're looking for.
We on our end also do like help with some like initial prototyping and proof of technology. So I'm part of our applications team over at EOS, and so what I'm basically is kind of like the first, you know, engineer interface with the customer. You know, maybe they're interested in buying a machine and are interested in the technology, but they want maybe like one or two, you know, parts to prove the concept and see if it's going to work. So we'll take that part in, we'll take them in, you know, kind of work with them on the design, because there are still some limitations design-wise, like on the metals aspect of it. You may have to design for the process, you know. We're getting pretty close though to trying to get away from that. You know, we have our Smart Fusion that allows us for lower overhangs, so we can get down away from that like 45-degree slope to like a 20-degree. So that really helps free up, you know, design possibilities.
I think the cool thing is you're using terminology here that I'm familiar with in my like home desktop 3D printer, right? Like the overhangs and
that.
You know,
so that's where I come from actually. I got interested in 3D printing because I was a hobbyist to start off with, and you know, I always wanted to get into it, and I graduated college and was ecstatic that I was able to start out in it.
This is
especially on
awesome.
the metal. I think the metal is something that's really cool.
Oh man! And so you are EOS.
Yes, sir. Main headquarters is over in Germany. We do have a big U.S. presence though. We only have 2 offices though in the U.S. We have one in Novi, Michigan, one in Greenville, Texas, which is right outside of Austin.
And we're just looking at avenues to keep airplanes flying.
That is actually like a very good application. I remember when I worked back at, say, a parts bureau, that was a big push. You know, a lot of casting houses over the years have left the U.S. or gone out of business, so there's no one to replace those parts. So additive is a big replacement for that, because say I only need 5 parts to replace those old components. Additive is great at that. Small runs of parts. It's a bit more cost per part, but when you think about the upfront cost, it's a lot lower.
A lot lower,
Otherwise, you would have to go down like either a billet or casting avenue. Billet's not an option. Like casting, I mean,
you gotta make the tool. You gotta, get the cleanup process. The tooling's a big part, right? Because a lot of the manufacturers that we deal with, the tooling's destroyed. It doesn't exist anymore. They haven't built this airplane since 1970, right?
And it was, industrial line tooling, so it's, a bunch of machines set up in series to make the part run fast.
And so we will never get back there. But, if I could send an STL and have a part made in a week.
And, the nice thing about it is, okay, I want to build 5 of this part, so I print one build of that, and then, I have another part I need to build. I can use the same machine and build that part.
Do the same part.
And I can even swap out materials. The beauty of, our small frames is to swap materials, it may only take, 3 hours.
So the same machine will do all the different types of materials?
So the polymer machines, they can only run polymer, and the metals machines can only run metal.
But it will run all the metals.
For the most part, if you're printing on a metal machine, it's going to run most metals. If you're printing copper, though, you may want to get a kilowatt, because the problem with the lower wattage lasers is there can be some porosity induced in the copper. Copper takes a lot of that heat away that it needs to properly melt. It's a very conductive material.
That's right.
But otherwise, pretty much every material will run on just one of our standard, 400-watt laser machines.
Aluminum is really our bread and butter, but there are a few stainless parts here.
I would say our 2 top materials are, nickel alloy 718 and aluminum silicon tin band.
There is just so much to see. Gotta keep moving.
You got some pretty hardware here.
Thank you. Hopefully it's not too bright for the camera.
Oh yeah, I gotta adjust some stuff here in a little bit. Wow. Tell us a little bit about what you do.
We're a prototype manufacturing company doing CNC cut. What makes us unique is we operate with materials starting from soft rubbers to titanium steel and everything in between. Quick turnaround, tight tolerances. Part like this, 0.4 millimeters thick, plus or minus 35 microns. I venture to say you won't be able to find anybody in the world that can do anything like that, because how do you fix it? How do you hold it? Talk to none of these machine manufacturers, none of these tool people will tell you can hold tolerances like that. We did.
There's no way.
We did. And they're not, this is secondary post-operative finished. That's off machine.
Straight off the machine.
Straight off the machine. As is the acrylic.
Whoa! Small batches.
Lot size of 1 out of blocks to a couple hundred end of our tools type of stuff.
This is amazing. This is really sharp. I'm recording all this because I'm trying to go back to the ones that I find fascinating, right?
Hopefully that's here. We're based out of Osaka, Japan, but we have production facilities in Marysville, Ohio. We just got started there a couple months ago, letting chips fly. We've got 2 machines there, 5-axis and a 3-axis. We're trying to figure out what the third machine should be, if that gives any indication. We're doing okay.
Wow.
I can't say any more than that. I didn't. Okay.
You didn't let the cat out of the bag.
No, I did not. No, I can't tell you how to fix it. I don't know. If I knew, I'd probably be shot.
Wow.
Probably utter it to somebody.
Trade secret.
Yeah, you'd be surprised how many times I'm behind my computer, I make up a little widget, and I can 3D print it as a prototype, you know, just kind of mock it up. But to go to that finished part, right, that is worthy of going on some of the stuff that we work on, old airplanes and old motorcycles or even new motorcycles. You want the quality, especially in aviation, you want the precision, right?
Absolutely.
That's, this is, I'm gonna get some more information for sure.
Yeah, but you
pretty
don't
good.
have to. Mind if I scan what you
Yeah,
got?
yeah, go ahead. I keep forgetting.
It says content creator, and that's okay, because that's not about what you're talking to me about. Right?
Exactly. No.
Although you can create content on that too. That's not what I'm saying. I'm trying to grade what it is that you're doing.
That's right.
No, so if you want, because you're into technology, you can utilize this and take a tour through our production facilities, basically.
We stumble into a few of these laser cutting booths as we walk through the convention hall, and it's really impressive the kind of work that you can put out using a laser to weld parts together. I'm really interested in this. I may learn about it some other time.
That looks like you ground it down. That looks so clean. Wow. Wow. And you get such a clean product.
This company is called Robotics, RBTX Robotics, and this line of robotic arm is called their low-cost robotics line. This thing starts at about $7,000 or $8,000, which isn't pocket change, right? I'm not walking around with that in my pockets, but it's not a barrier to entry. The investment up front would be significantly lower than it was a few years ago for getting into a system where you can have a camera mounted on it or over it, and it will be able to sort nuts and bolts, pick up shop rags. You can tell it exactly what you want it to do, and they will build out this thing as a solution. Now, I can't give you the perfect solution because everyone's situation is going to be different, but at this starting price, it means that a person like you, or maybe I, can get into robotics and automation for making things around the hangar, around the house a little bit more easy. So think about where this can go, and maybe drop a comment down below and tell me what you can imagine using this thing for. I don't have a giveaway, but I know who to ask if we could get
All right, we're checking in from Flow, which is a Waterjet cutting operation or a company. They manufacture and sell water jets, which is one of the more popular ways to cut sheet goods or even up to thick steel. That Waterjet has, you know, tens of thousands of PSI of capability, and it'll slice through anything just like butter. But it can also be delicate and do things like foams and cork gaskets and rubbers and neoprene. So really versatile. This one's huge. I couldn't fit it in a garage if I wanted to. But it's just nice to see the capabilities. And all of these manufacturing operations are telling us, if you have things to be made, give us a call and we can figure something out. We can talk through the path to getting parts from SolidWorks or Fusion onto a Waterjet or a CNC machine or a 3D printer. They're saying it's all possible and they'd be happy to help out. But this gigantic thing back here is more capable than anything I'll ever need, but I want it. I really do.
I saw comments on the previous video when I talked about parts availability and the cost of parts, where people think that these manufacturers won't do airplane parts. A lot of them already work in the aerospace industry and supply parts for the brands that you know and love. You know, think Textron and Bombardier and all the other things that you can think of. So when I brought up the idea of making parts for small airplanes, they just said, yeah, that'd be super easy. No complaints, no worries, no kickback about not being able to do airplane stuff, just solutions. So go out there and see if someone in your neighborhood might have capabilities like this, and see if they're familiar with providing parts to small airplane owners or manufacturers. That's your path. Hope that helped.
Okay, here's a thought. Everyone has a robotic arm now. Every manufacturer is doing something with robotic arms. So they're creating ways that they can minimize human interaction with all the machines.
Robotic arm grabs the thing, puts it into the machine cuts the thing, machine takes the thing out of them. You know, it's just, the whole process now is a little bit more automated than it's ever been. So all of the stuff that's here, a lot of the manufacturers here are doing automation, automatics, auto everything, making it a lot easier to get to finished products. You hit the button, you hit print, and it just goes. Let's take a look at this machine over here. Right, this is exactly what we were talking about. There's a robot arm that will grab the raw material. The door will open automatically. It'll put the raw material inside the lathe, close the door, run the machine process, take the finished part out, and then put it back on the tray. So when you get back in the morning, you have all of your parts made, the machine has done it all, you move on with your life. This is the state of the technology, and it is amazing. It is mind-blowing, really. All right, so the cut is done. The raw part there's the finished part. And it's ready to put in the new part. No way. So it does automated chip clearing, it does cleaning after the process, everything. It eliminates the I want one.
It's the union's worst enemy.
It really is, right? But like, things have got to change sometimes, and now's your opportunity. I talk about this stuff every now and then, but I've never actually seen it in action. And it's almost kind of creepy, right? Like, but I like it a lot.
Any questions regarding custom manufacturing service?
Whereabouts are you based?
California.
California, okay.
Los Angeles.
Yeah. So a service like, so let's say, you know, I'm kind of handy with Autodesk Fusion or SolidWorks. Can I just send a step file over and?
Yes, step file and the PDF drawing.
Yeah.
And then tell us how many pieces you need, and we can quote you.
So you know, I think about years back when I sent something out, I needed to have a properly dimensioned drawing and I needed to have all of this extra stuff. If I don't know how to do that, could I just still send the part that I need? I just send it over and you do the rest. You figure it out.
Yeah. You need you have a sample, okay, you have a part, and you need somebody to help to do the files, drawings. We can get up.
That is the way. That's what we're talking about.
It's somewhat in the business of restoring old aircraft, and most of the components are no longer available.
Yeah.
So companies like yourselves can be very useful for replacing parts.
Yes.
And things like that.
Yeah.
Thank you.
Because we have at home we have 3D scanners and very basic capability to use SolidWorks or Fusion.
Yeah.
But then getting the part made and a quality part made is usually the difficult, the difficult part.
Yeah.
So services like this I think is going to be very handy. That's actually really good.
Yeah.
I'm going to grab one of these.
Yeah.
Propeller blade right here. So they must do airplane stuff. That almost looks like. How are you doing, sir?
Good, I'm very good. How are you two?
Very good.
I don't want to ruin your video.
Oh, no. You're going to be just fine.
But did you have any questions or you want to know about the configuration?
I have questions.
Let it rip.
So we're small airplane people, so we saw the propeller over here.
Oh, right on.
And so you're doing, right, is it metrology scanning? Is
Yes.
it, what is, okay.
So it's metrology grade scanning.
Okay.
So the laser, this particular laser, is a 1.9 micron repeatability laser. So it's for small, tight parts.
Oh,
Yes.
yeah.
And then the white one there, that's the L100. So you're stepping back into 5 to 9 micron range, but you get 100 millimeter strength. So you're just a bigger paintbrush. So we have some in between.
In a situation like this, I provide the computer with a known good CAD model. I give it what I want it to be,
Yep.
and then you scan it and just compare it against that known.
But that's it. But there's more to it than just that. So taking the raw data and giving you a color map and showing you where the deviation is and like the flow, that's important.
Yeah.
But then we also have prismatic features like the hub, like those undercuts. There may be specific callouts on the radius along the edge and trailing edge. So you're also getting that data from it. So you have your prismatic stuff, your measurements, and then a comparison.
Do you have some propeller shops using the technology currently?
Yeah, and it gets weird, right? So if you do propellers, which I'm assuming you do.
We don't do them directly. They're on our indirectly. They're on our products, but you know.
So in the turbine blade side, either cold or hot section, absolutely all of it. Laser scan, optical scan, we do that all day long. If you're flying on a plane, probably measure on this.
Yeah, right.
For propellers, because it's still FAA, the FAA data goes back so long. These Hartzell, they've been making them forever.
Yeah.
You're still taking like linear measurements.
Yeah.
It's still off the print.
Exactly.
So for this, yes, we're giving them the form data. Yes, you can. In process, you're helping your machinist make good parts or your casters make good parts. But then the final check is still going to be to that certified print.
Exactly. Yeah, because no one's done the work to try to figure out how to convert that print to a CAD model, right? Yeah. It would take a college student one day to do it. The FAA,
but
10
then
years.
every propeller in the entire world
Would have to be, yeah.
I know.
Okay, that's fair. No, this is cool. This is really cool.
Yeah, my first passion was actually flying.
Right.
Yes.
We flew up today from Savannah in Bonanza.
Oh, wonderful. Cool. Yeah. I did the whole bit. I'm a flight instructor and all of that. And then, as 15 years ago-ish, I had a lot of different. I couldn't walk for 2 years, so I just derailed my entire career. But now I'm in trouble.
Yeah.
And I sell to all the big aviation houses.
Yeah.
Because it's still, you still have your CFI? I do. Yes, I keep everything.
Yeah. But now you're doing the work that's required to keep your planes flying, which is.
And oh my gosh, the things that they do.
Yeah, trust me. We know. We know. We know. We get it. Hey, thank you so much for your time. This is very, very helpful.
Safe travels back.
Hey, thanks. Yeah. I'd shake, but there we go. Nice. An X-ray machine that is small enough to fit on your desk for NDT work. That's pretty cool. All right,
so we have instant quoting on our website.
That is perfect. That is awesome.
And we're much smaller, but we're much nicer than ours.
This would be awesome. So the normal file formats, DXF, step files, 3MF, that kind of thing, you'll just take them and run with them?
Yeah, so and you can put like even the set files into the quoting system and it'll unfold, as long as it's just sheet metal stuff.
Sheet
if
metal.
it's not got any tubing or anything on it.
Most of the stuff we deal with is sheet metal, so this is cool. These are some of your parts right here.
Yep. This is straight off of the laser. So
oh wow! So no deburring, no finishing, and it's still pretty good.
Right.
That's still
Especially
really
for
good.
that thickness.
That's actually really good.
Yeah, that's a heavy piece too.
Yeah, that's an easy cleanup. That's a 30-second whiz.
Tell my guys that. So, and then that's off the Waterjet. So we have a Waterjet as well.
So Waterjet and laser, and
What's the cost comparison between a laser cut parts versus waterjet parts?
So Waterjet is a really slow cut.
Right.
So laser's much more efficient. But like if you were wanting to cut like 8 inches thick or even over like 1.5 inches, you're going to have to switch over to the Waterjet because my fiber laser is only 6 kilowatt.
Yeah.
So
that's plenty.
Yeah.
And you in-house bending services too.
Yes,
Okay. Wow.
And we can fabricate if you need fabrication or welding.
Oh, that's good to know.
We do countersinking, but we don't have a 5-axis head, so it's just manual countersinking and tapping. And stuff like
The
that.
kind of stuff we do, we don't need 5-axis, nothing. We just need a little bending, a little sheet metal cutting, and there's so much I could do with that already. Right? So that's perfect. That's open source GA is my YouTube channel. So
okay.
Yeah, we're trying to do things with small airplanes, trying to give owners of airplanes options for making parts that no longer exist from the 40s and 50s and 60s. That it's a simple part, it might be a bracket, right? It's 6061 or 5052 aluminum or whatever it is. Yep. And you can very easily make them today. Whereas in the past, it was you had to have an engineering degree to draw up the things and do all this stuff. You still need that, but the service that could turn the drawing into a thing is now so much more accessible. I'm trying to show people that that's the case, right? So, yeah, this is awesome. This is really, really good. Yeah, I am. Where are you based, by the way? Oh, Nashville?
No, Asheville.
Asheville?
Yeah.
Right, even better.
We're compared to you guys all the time. Savannah, Asheville, they're all so similar.
I'm just thinking I can send you a part, you can make my part, and I can just come get it, right? It's like that close, right? Like,
or I can bring it to you.
Yeah, oh yeah. No, I appreciate this. I really do. This is great. I've been looking for more of the service. The parts, the machines are cool, but I can't afford half of them. Well, I can't afford any of them. So I'm glad you can so that I can take advantage of it, right? So thank you so much. Appreciate it. You could probably do a whole panel.
Is that printed on?
Yeah, that's yeah. Yeah, so we very well now that I've seen this. Okay. Yeah, we do a whole bunch of like the little airplane panels, small general aviation panels, and the hardest part of it in the end is doing all the placards and all of the markings and all of that kind of things. That's exactly where you come in. Yeah, that's exactly where you come in. So tell us a little bit about the process, right? And I'm recording here just so I can have some notes for some people online. But
sure. So the product we make is metal photo. This image is actually photo image into the metal itself. So it's smooth touch, it's not an ink or dye. So on control panels where you're touching, messing with everything, it's not going to wipe away or wear away. You can clean it with chemicals, you can clean it with any kind of abrasive chemical you want on there. It's not going to hurt it at all. So that's our bread and butter material. We also work with all sorts of plastics and overlay materials, warning signs, labels, that type of thing. But typically, the metal photo, when it comes to control panels, is definitely a good option for you guys.
Do small batch.
So we do have an order minimum of $400.
Okay.
So that could be, depending on the control panel, it could be one piece, it could be several pieces. It really depends on shape, size, any kind of fabrication work that has to be done. So we have a complete fab shop in-house.
That's pretty sweet. So I would send you let's say a DXF or something like that, and
drawing. We love any kind of vector-based drawing files.
And then maybe something else calling out the colors and calling out the logos and that kind of thing.
Yeah. If you've got all that information sent to us, we can get it quoted up for you. And then as long as we have all that files, if you guys go to order, our graphics team will lay it all out and send you guys to art proof for approval.
Yeah.
Once you guys approve it, it goes right into production. Typical turnaround time is about 15-20 days.
Yeah, okay. And full products. You drops it. Oh, wow. That's not bad. Because, I've got the capability of like prototyping I got a small laser cutter at home, a Bolt, I don't remember, Thunder, a laser. But I only cut cardboard and MDF on it so I can get the general shape of what I need, but then the finished product is kind of what I'm looking at you like, well, now I know it fits, let me send it into production, right?
Yeah, get all the measurements for us, and are you looking for like a thicker control panel, or do you have an idea on thickness?
So it varies, because the standard instrument panel that we do is probably 40 thousandths, 040 up to maybe 090 sometimes aluminum. But yes, it's so thick, but a lot of it too is cosmetic. So sometimes you have an existing panel and you just want to put an overlay on top of it that's real thin. Yeah.
So we go as 3 mil.
Yeah, okay.
0 to 3.
Yes,
So
that would be
thin.
perfect.
And what we can do is over here. My bad. So we do a lamination process.
Okay, yeah.
So we have the aluminum on the top.
Yep.
We can either do a plastic backer or aluminum backer as well.
Yeah, that's like ACM. Like, yeah, that's perfect. That would be perfect right there. It'd be rigid as hell, right? So
yeah, it's not going anywhere.
yeah. Man.
There's a saying that goes like, all playgrounds must close, or all good things must come to an end. I don't know. Here we go.
Yeah, so leaving the manufacturing technology series here in the Southeast, Greenville, South Carolina. Thoroughly impressed. Lots of automation, getting lots of AI sprinkled into all of the bits and bobs. Excellent tooling, excellent tool holding, but a lot of concentration on parts inspection, part quality, which I find impressive, because we know how to make parts. We might not know how to ensure that what you've made is what you actually want. So a lot of the things that we saw on the inside there had to do with parts quality, post-manufacturing inspections. We even see them inspecting a propeller blade that's been stripped down and trying to match it up with a print, a CAD model. So that's pretty cool to see. Other interesting things is, like I was trying to say inside, every booth had some sort of robotic arm. And I think you see where this is going. We're gonna have 2 robotic arms, maybe a torso, maybe 2 legs, and all of a sudden, the machines don't need humans anymore. The humanoids will start taking over, manufacturing these things. Now, if that brings prices down, I'm all for it. Is it losing us jobs? It probably is, but that's not where I spend most of my time focusing on, or most of my time figuring out. We need to move people around, we need to do other things so we can keep aviation affordable. Parts manufacturing is one of those things that we're gonna have to do and figure out how to do ethically, smoothly, so we can have old small airplanes. Where are the stairs? Oh, they're all over here, great. Yeah, there we go. Now, so back to Savannah, up in the Bonanza, do a little bit more instrument work on the way home. Enjoy the ride. It's pretty gusty up here, but beautiful day otherwise. All right, catch you in a little bit.
What a day. And I know this was a long video, but I thought many of you might get content that's worth watching from what we did today in Greenville, South Carolina. We went back to the airport, hopped in the Bonanza, filed a flight plan, flew at about 7,000 feet, did 195 knots over the ground, pretty much consistently at 65% power, shot the RNAV 28 into Savannah for a full stop, and then shut down, put the airplane back into the hangar. That's the summary of the flight on the way back. But the other things that we accomplished today was showing you that the technology is advancing very, very quickly. More rapidly than even I realize in some instances. The robotic arms and the CNC controlled bending machines and the laser scanners and the laser welding, and it's all coming together to form solutions to the problems that we're having in general aviation. If you're not talking solutions, you're wasting your time. We can do better. I think there's a future here for us, and we're going to be a part of the solution on this channel. Thank you for tuning in. Empty your pool. It's getting cold outside. You don't need it anymore unless you turn it into an ice bath. All right, that's my advice for today. We'll catch you later.